Hello, welcome to my live stream. This is Homework Help. I'm Beth from my Tutoring Bee. We are going to be going over a few different problems here. So let me get everything set up for us while I'm also going to tell you about our, I'm going to be putting in the comments, sorry, I'm going to be putting in the comments some of our rules and guidelines that we like to go over, and then we're going to get into some homework topics here. So give me just a moment to do that, and then I'm going to kind of talk through what we're going to be working on. So for these live streams, my goal is to go over some homework that some of my students have given me, or not given me, but asked for some help with over this past week. And so this will hopefully give viewers a little bit of an idea of what tutoring with me looks like. I am a private tutor, and I work with students from second grade all the way through high school. For high school, I work with kids in Pre-Algebra, Algebra 1, Geometry, and Algebra 2. I have started to get into statistics. I am not really great at that yet. It is something that is a skill that I have always somewhat struggled with, even when I was in school, but I'm getting better at it. I'm doing some classes over the summer, so you can look for that in the future. That is something that I plan on offering in the future as one of the subjects that I tutor. Okay, there we go. There are all of my guidelines in there. And let's go ahead and get started. I'm going to attempt to share my screen here. I am still pretty new to do live streams, so bear with me as I get this going. There we go. I've got that. And then my dashboard. Okay, just making sure I've got everything so I can see comments so that you can see my screen. We're going to be going over some geometry to start off with. This is a skill that a lot of my students have been working on recently. So one of the things that I found that some of my students are kind of, maybe not struggling, but this is one of the more challenging areas, is dealing with surface area and volume for other prisms. So prisms that have bases other than rectangular shapes. So let's go over one of these triangular prisms. I think I want to try number 5 today. Let me get a better color for that. We're going to go over number 5 in this problem today. And the reason I wanted to choose this one is we have a lot of different dimensions that are listed here for this particular problem. And that's the thing that students get tripped up with the most, is all of the different dimensions, not knowing which ones to use for the formulas. They know how the formula works. They know how to sub in numbers for those formulas. But yeah, so it's one of those things that is tricky to know where to get those numbers from. So let's go ahead and first work on we're going to find the surface area of this one. So our surface area formula, they've got it listed right here actually, is HP plus 2B. And this is a capital B on purpose. So let's talk about what all of these different things mean. So H is the height of the three-dimensional shape. Now, when we have prisms that have a base other than a rectangle, sometimes it can be misleading because it looks like this rectangle is the base of this prism. However, it's not. It's whatever the other shape is. And in this case, it's a triangle. So this triangle right here is what we are going to be using as the base. So it's almost as if this has been sort of laid over on its side. And then this is what it would normally sit on, like that's the part that would be on the ground. And so then that means that the height is the distance between the two triangular shapes. So the height is going to be this length right here, which as we can see here is 3 kilometers. So I'm going to go ahead and sub in 3 there. Now the P stands for perimeter of the base. And as we just talked about, the triangle is the base of this shape. So we need the perimeter, which is, it looks like 5. I'm going to highlight some of these. Looks like 5 is this side length. 12 is this side length. And then 10 is this side length, right? So sometimes we have to look across to see what those matching measurements are. So we're going to do 5 plus 12 plus 10, right? For perimeter, we're going to add all of those dimensions together. All right, and then we're going to have plus 2 times the capital B is for the area of the base, okay? So we talked about that the base is that triangular shape. I'm going to erase all of these markings here so that it's not too cluttered. So what is the area of a triangle? The area of a triangle formula is 1/2 base times height. So you can see why this gets a little bit confusing for students, because now we've got another H for height, but now we're just talking about the height of the two-dimensional shape of that triangle. So we always want to find that 90-degree angle for the triangle so that we can use those two dimensions that make up that 90-degree angle. So the height for this one is going to be 4.1, and the base for this one is going to be 12. So we've got 1/2 times base times height. So I'm just going to go ahead and write that down here. All right, so that is the hard part. Now the easy part is just calculating this. And so of course, we should know order of operations. At this point, we're going to figure out what those things inside the parentheses are. We're going to figure out what, and then multiply, and then add these two quantities together. So let's see what we've got. We've got 5 plus 12 is 17, plus 10 more is 27. So we've got, whoops, not 2, 3 times 27, plus 1/2 of 12 is 6, and then 6 times 4.1, 6, 24, and then our decimal in there. So we've got 2 times 24.6. All right, and then 3 times 27. So I'm just kind of writing this stuff all over the place here because we're just doing this one problem from this page. So that's 21, 6, 7, 8. So we've got 81 plus, and then 24.6 times 2. That's 12, 8, 9, 4. Just doing those calculations pretty quickly so that we can get on to the next problems here. And then we just need to add those up together. Don't forget to line up your decimals, line up your place values. So we've got 10, 9, that gives us 13. So we should get a surface area of 130.2. And this is a total surface area, not a lateral surface area. Lateral surface area, you can see the formula here. It just eliminates that plus 2b, that 2 times the area of those two triangles. But this would be our total surface area. All right. Let's check. Okay, I don't see any comments or anything yet. So we're going to go on to this page, solving using quadratic formula. This is another skill that a lot of my students have been asking for help with. So let's talk about what the quadratic formula is. I've got a couple problems over here. First, I'm going to write the quadratic formula for us. So quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, So let's talk about what A, B, and C mean. I'm going to go ahead and grab this problem number 6 right here and write it down right here. So we've got 2x squared plus 3x minus 20 equals 0. All right, so first, we want it in this format where we have our A, B, and C term equal to 0. So if you get a problem like number 8, where you've got something other than 0 over here that it equals, you want to get rid of that. For this one, we would add 10 to both sides, add 10 here, and then we would have our A, B, and C. But our A, B, and C are simply the coefficients for each of our terms. And I'm going to highlight the sign in front as well, because that does matter. So A for this particular function is 2, B is 3, positive 3, and C is negative 20. Okay, so you see that I pulled that negative, or that subtraction sign. We're counting that as a negative for that 20. And now we're just simply going to sub those in wherever we see A, B, and C in our formula. So negative B, since B is 3, we're going to have negative 3 plus or minus the square root of 3 squared minus 4 times A is 2, and C is negative 20. And that's all over 2 times A, which is 2. Okay, so that's how you use the quadratic formula. And this part is somewhat straightforward for students. Finding this part in here can sometimes get tricky. This is called the discriminant. So it's a fancy word for the part that's underneath the square root. So, so let's go ahead and solve that. I like to rewrite that out to the side. So I'm going to rewrite that here. So we've got 3 squared minus 4 times 2 times negative 20. And again, we want to use order of operations. So exponents first, that gives us 9 minus, and then we can go ahead and do our multiplication. 4 times 2 is 8. Times 20, so 8 times 2 is 16, plus another 0 is 160. But that 20 is negative, so that's going to change this to a plus 160. Okay? All right, and then we've got 9 plus 160 gives us 169. So that's why I like to write it out to the side here, because rewriting all of this over and over again that takes a lot. 2 times 2 underneath here is 4. So we can go ahead and do that part now. So now, hopefully this looks a little bit more simplified for us. It's a little bit easier to read. And now we're going to go ahead and find the square root. If your square root is a perfect square, like this one is, then you can go ahead and write in what that square is. So the square root of 169, I believe, is 13, but I'm going to just double check that with my calculator. Yes, 13. So the square root of 169 is 13, so I'm going to rewrite this as negative 3 plus or minus 13 over 4. Okay, so far this has not been too challenging. This is the part where a lot of students don't know what to do, or they think that this is the end of the answer. However, when you come up with a whole number here, when your square root is a perfect square, you can actually solve this further. This plus or minus means that this is 2 separate problems. We are going to add negative 3 plus 13, and then we are also going to subtract negative 3 minus 13. And that's what's going to give us our 2 separate answers. So I like to write it like this and do 2 separate problems. So negative 3 plus 13 over 4, and then negative 3 minus 13 over 4. Okay, let me move this out of the way. I'm going to discriminate here. All right, negative 3 plus 13 is 10 over 4, and then we want to reduce that. So 10 over 4 gives us 5 over 2. And then here we have negative 13 minus 13 gives us negative 16 over 4. And then negative 16 divided by 4 gives us negative 4. So those are our 2 answers. So x equals 5 over 2, or x also equals negative 4. Okay, so that is one way that you can find the solutions to any quadratic equations that you have. Okay, let me see how we're doing on time here. All right, I wanted to do problem 8 as well, but I have one other type of problem that I want to make sure, simplifying radical expressions. Let's go ahead and do simplifying radical expressions. And then if we have time, we can go back and try that other problem with quadratic equation if we have time. So let's try this one. Okay. Which problem should we do here? I think I'm going to do, now, as you can see, this is a picture that one of my students sent me. They needed help with their homework, so they sent me this ahead of time, and then I'm able to put it up here on the whiteboard just like I am for this live, and we work on it together. So, and you can see that they have attempted some of these problems, but there was a little bit of, they needed to go a little bit further for some of their work. So I'm actually going to do problem 2, part A. And the directions say to rewrite in simplified exponential form. So we don't want it in radical form, we want it in exponential form. So let me rewrite the problem here. We've got the cube root of 64x to the 7th. All right, and then you can see here that they simplified it to be the cube root of 64, and then they wrote the x with the exponential, with the fractional exponent there of 7 over 3, which is correct. We just needed to go a little bit further with that. So let's go ahead and just mimic that, what they did, and go ahead and separate that out, and then we've got x to the 7 over 3. Okay, so we've got that part so far. All right, let's go ahead and talk about the cube root of 64. We always want to simplify our roots if possible. I have a ton of other videos on my channel about how to simplify square roots, cube roots, nth roots. One of the main method that I like to use the most is the factor tree method. So that simply means that we are going to split up all of our numbers into prime factors. We want to get down to nothing but prime factors. So 64, that is, and the reason I like this method is you can choose any factors you want. You don't have to use prime numbers, like you don't have to divide by prime numbers. So 64 is 8 times 8, right? I also could have done 4 times 16, right? So that's, it gives you a little bit of freedom with the factor tree method. All right, and then 8, we're going to keep going. We're going to split that up into 4 and 2. 2 is a prime number, so I'm going to circle that. That kind of ends that branch. But then 4, we can continue factoring into 2 and 2 as well. And then the same thing here, 4, 2, and then this can be split up into 2 and 2. Okay, so now we've got all of our prime factors. Just checking, making sure I'm not missing any comments or anything over here. And because it's the cube root, right, we've got the 3 here. That means we are looking for 3 of the same number in order to bring that outside of the radical. So we do. We have 3 2's right here, and we have 3 2's right here. They don't have to all be in the same group like that. It doesn't matter where they come from, as long as you have a group of 3 of the same number. So each of these comes outside of the radical. Let's go ahead and write our equal sign up here, over here in our cube root. Each of these come outside of the radical as a single 2, right? So this gets represented as a single 2, and then all 3 of these gets represented as a single 2 outside of that radical. All right. Now let's talk about 7 over 3, that exponent of 7 over 3. We can simplify that a little bit more as well. So one way that we can think about this is how many times can 7 be divided by 3? Well, 3 can go into 7 twice, right? 3 times 2 is 6. But then we've got 1 left over. If we want to write it like this, if this is more easier to think about with those remainders, then that's fine. So it goes in twice. That's 6. And then that's our remainder of 1. Okay. So when we think of it that way, we can kind of see, okay, well, how many groups of 3 of these x's do we have? Because remember, this x to the 7th power, we could write as x to the 3rd times x to the 3rd times x, right? 3x's multiplied together times another 3x's multiplied together times one more x multiplied together. That's 7x's multiplied together. So how many groups of 3 do we have? Well, we have 2 of them. So I actually need to give myself a little bit more room here, because these 2, right, each of these are going to be represented as an x, as a single x. In other words, these 2, our whole number that we got when we divided, is what our outside exponent is going to be for that variable. And then we have this single x left over, or that remainder, and that's what is going to be left inside the radical, because we don't have enough of the groups of 3 to pull that outside of the radical. Okay, so now let's just simplify this, clean this up a little bit more. 2 times 2, let me go back to purple here. 2 times 2 is 4. We've got x squared and then cube root of x. And that would be our simplified answer. Oh, wait, sorry, hold on. I forgot that it asked us to write this in exponential form. So we actually don't want this radical here. So we want 4x squared, x to the 1/3 power. There we go. And we can actually multiply these two since we are multiplying. So it would be 4x 2/3. That doesn't look like an exponent. Sorry. There we go. Okay, great. All right, let's see what else we can get into here. How are we doing on time? We're at 22 minutes. Let's do one more. Let's go back up here to our quadratic formula. We do have a little bit of time that we can do this one. So let's do problem number 8 here. So we've got 2m squared minus 7m minus 13 equals -10. So remember before I said that we need to make this equal to 0. So we're going to add 10 to both sides of the equation. 2m squared minus 7m, and then that would give us -3 equals 0. Okay, so now we have our A is 2, B is -7, and C is -3. Kind of going through this quickly. This isn't as quick as I would do it in a tutoring session, but since I don't have somebody here to like kind of bounce off of, it makes it slightly, the pacing slightly different. Okay, let's go ahead and sub those numbers into our quadratic formula. So our b term is already negative. So when we plug it in here for -b, it's actually going to become +7. Plus or minus the square root of -7 squared minus 4 times a is 2 times c is -3 all over 2 times a is 2. Okay. All right, let's go ahead and do that discriminant. Remember, I like to write that off to the side because then I don't have to rewrite all the rest of this equation. So -7 squared, and I am putting that -7 in parentheses on purpose, times 2 times -3. So -7 squared is -7 times -7, which is +49. This is a pretty common mistake that a lot of my students will sometimes fall into because they see that negative and they'll say -49. But because it's negative times negative, that cancels out. So we get 49. And then 4 times 2 is 8 times 3 is 24. We've got this negative and this negative that will cancel out with each other. So we're going to wind up with positive plus 24, right? 8 times 3 is 24. Okay, yeah. All right, and then when we add these together, we are going to get 4 plus 9 is 13. Then 4 plus 2 plus that extra 1 that we carried over is 73. So let's go back and sub this in. This all equals 73. I'm just going to rewrite that right here. 7 plus or minus the square root of 73 over 2 times 2, we can go ahead and do that part, is 4. All right, so 73 is not a perfect square. So we do want to try to simplify this if we can. I'm actually not sure if 73 is a prime number. Let's try. What I like to do for this is I will just plug in 73 divided by, and I'll try different things in my calculator until I get a whole number. So that's what I'm doing on my calculator, 73. And sometimes you can go up to, like, some of the 2-digit numbers will help, like 13, especially with an odd number. I would try like 13, 17. None of these are working. 73 divided by 7. No, that wouldn't work. I think this might be a prime number. So that means that we're just going to leave it just like this. This is our simplified answer. And if this denominator were to cancel out or do any simplifying with any of the top numbers, it would have to be with both this whole number out in front and anything that we simplified out of that radical. So, as this would be our final answer, that x equals, and this is two separate answers because of that plus or minus. X equals 7 plus square root of 73 over 4, or x equals 7 minus square root of 73 over 4. Okay, so a lot of times we just write it like this with the plus minus to save ourselves a little bit of time and space. All right, that is it for my live. If you have any questions for me, please let me know. Drop them in the comments below. I'd really love to hear what you think about this format. I'm thinking about doing this on a more regular basis. We'll kind of see. I'm kind of curious what kind of feedback and response that I get from these. And if you have any homework questions that you have questions about, then you can also let me know about those too. And I'll see you next time. Thanks. Bye.